Okay, let's try the other way of making a PDA for this. It'll necessarily be non-deterministic but less complicated by just creating the grammar and then converting the grammar with the algorithm. So what's a grammar that produces center-marked palindromes? So I got S. I guess S could go immediately to dollar. Or I could put a 1 on the left, 1 on the right. Or I could put 0 on the left, 0 on the right. So this looks like the grammar to generate center-marked palindromes. So then we just do it. So initialize, reading no input, reading the end of stack symbol, push SZ to go to Q1, and Q1 is the powerhouse, it's the only state that does all the work. So read no input, read S, so this is stage 2, which is of expanding non-terminals. I can replace it with a dollar, or I can replace it with 1S1, or I could replace it with 0S0. I can also match terminals, so if I see a 1 on the input, 1 on the stack, match them, 0 on the input, 0 on the stack, match them, dollar on the input, dollar on the stack, match them, and then the final state is going to be empty input, empty stack symbol. Let's be careful, so let's check our algorithm. Here we go. So I did all these cases, expanding all the non-terminals. Epsilon S push the thing, epsilon S push the thing, so that's fine. Match and pop, so for all terminals, I match them and I pop them. And then when I terminate, when I see Z. Okay, there we go. So Q2 is a final state. C epsilon, C Z, pop the Z, go to Q2. There we go. Clearly, this is a non-deterministic pushdown automata because at Q1, there's like 6 different transitions and a lot of them overlap. If you see epsilon S, there's 3 different choices to make. That makes this thing here a more complicated pushdown automata, but it's deterministic. And this is less complicated, but it's non-deterministic. So much like an NFA and a DFA, you pay for the determinism by being forced to take extra states, right? So non-deterministic, harder to evaluate, fewer states, easier to design. Deterministic pushdown automata, more states, easier to evaluate, but harder to design. And again, because these machines here, NDPAs in general, NPDAs, whoops. In general, these machines, non-deterministic pushdown automatas, are strictly more powerful than deterministic pushdown automatas. This in general might not even be possible. So for example, if you were doing the language W reverse, where W is a binary string, but it's got no dollar to mark the middle, my deterministic pushdown automata won't know when to stop reading the first W and start popping the second W. So we won't prove it here, but it's actually impossible to create a DPDA for this language here. Cannot be done with a DPDA no matter how hard you try. With DPDA. Okay? Intuitively, because it has to guess where the middle is.